Okay, good morning, everyone. Um, my name is Jeffrey Wolf, and I'm here to speak about the Veritrace project, which I'm a part of. And I apologize, it's going to be a bit of a whirlwind, but I hope to get through and to explain what we're working on. Hold on a second here. Here we go. Just some quick background here. We're a team of 5 based out of Brussels. I myself live in Berlin, but we're based out of Brussels. We have a PI, Professor Cornelius J. Schilt, and the 4 of us, we have a classicist and a couple historians. I'm a historian myself, a historian of science and medicine, but for this project, I'm the digital humanities person. In fact, I focus on the 18th century, and where we end is where my own intellectual interests begin, but I'm doing the digital humanities stuff for us. Context about the project itself. This is a 5-year ERC starting grant project. And what we're trying to do is trace the influence of what's called an early modern ancient wisdom or Pisca Sapientia tradition on the development of early modern natural philosophy, early modern natural science. And you can find this tradition in works published with titles like the Chaldean Oracles, the Sibylline Oracles, the Orphic Hymns, and probably most famously, the Corpus Hermeticum, for those of you who study the history of chemistry and so forth. So there is this tradition there. That's sort of our close reading corpus, if you like. We have 140 works that represent that tradition. And we know it had an impact on the development of early modern natural philosophy. We know Newton read the Sibylline Oracles. We know Kepler knew his Corpus Hermeticum, among other things. But we want to go deeper, and we want to uncover a much broader set of networks and texts that engage with this tradition. One scholar has called it the great unread. A lot of these works are never the focus of historians. There's so many of them, often by lesser-known authors. So that's our focus. Let me just set the framework in terms of computational HPSS. What we're trying to do is bring large-scale multilingual exploration to this research project. You'll see we have some tools for keyword search. We also want to identify textual reuse, both direct, so when someone is doing a lexical direct quotation, maybe it's not cited, but they're using it from another work, and more indirect stuff, where it's a paraphrase or it's very indirect, but for someone reading it at the time, they would know it came from, say, the Corpus Hermeticum. So, and we have a very large multilingual corpus. We're trying to build, if you like, an early modern plagiarism detector. And we want to uncover networks of texts, passages, themes, topics, authors that have potentially been ignored. So not just focusing on the big names. And perhaps we come up with some new patterns in the intellectual history and philosophy of science by doing that. How are we going to do it? We have a large, diverse, multilingual data set. We're focused on printed books, printed texts, so we're not focusing on handwritten stuff, unfortunately. We have 3 different data sources, 6 different languages, and the works are published almost over the course of 200 years. We're starting in 1540 for various reasons, and we're ending right after Newton dies in 1728. That's our time period. Our main data sources are the early English books online, which you can download yourselves for free. Gallica, so we've downloaded sources from the French National Library through Gallica. And our biggest data source is the Bavarian State Library for a total of about 430,000 books that is in our corpus. And we're going to use state-of-the-art digital techniques to explore that. Some of the core challenges that you can probably already guess at for this project, variable OCR quality text. Okay, we're getting the text directly from the libraries themselves. They've scanned it. They provide us not even with the page images, just the raw text. So XML files, HOCR files, even HTML files. And of course, that affects everything downstream. How are we going to manage that? Early modern typography and semantics in at least 6 different languages. Okay? Lots of challenges there. And of course, we have a lot of data, hundreds of thousands of texts printed across Europe for over 200 years. Current LLM use, I'm going to steal some language from yesterday, so thank you for that. On the decoder side, we're using GPT-based LLMs to help us enrich and clean our metadata. We're using LLMs as judges to help with this. Unfortunately, I'll talk a little bit about it, but I don't have time to tell you about that. I know maybe some of you that would be the most interesting thing, but that's not what I'm going to focus on today. I'm going to focus on the encoder side. So how we're using BERT-based LLMs to generate our embeddings to encode the semantic meaning of the sentences and passages in our textual corpus, because we want to do some text matching, as I mentioned before. So here, unfortunately, is the case study that I would love to talk to you about. It's more technical, and our use of LLMs as judges to enrich our metadata. I will tell you at the very minimum that I can't say that it quite works yet, and there are some reasons for that. But basically, we want LLMs to do what is extremely tedious for us as a team to do by comparing bibliographic metadata, pairs of records that may or may not represent the same underlying printed text. Each team member had 10,000 of these pairs to review. You can imagine extremely tedious, so we wanted LLMs to do it for us. We have a series of LLMs. If you want, you can call it a bench, because we're using a panel of judges of LLMs to do it. Extensive prop guidelines output, which is kind of interesting, along with their reasoning about why the match is or is not representative of the underlying text. And it's a work in progress, okay? The major challenge for us right now is that we get a lot of hallucinations, actually. Now, these are not frontier models. They're open source stuff, Llama and so forth, but a lot of hallucinations in the output. And when you ask them to provide you more structured output to get rid of the hallucinations, which you can do, they do get rid of the hallucinations, but they're kind of cheeky about it. And they give you very generic responses, and the reasoning they provide is much less helpful. So there's sort of an art here, a balance that we're still trying to work on. We think there's a lot of potential for this to save a lot of time, but so far we haven't got it quite to work, but your advice is very welcome. But I can't talk about that today because I want to focus on our other use of LLMs, and that is through our Veritrace web application, which is, I just warn you, it's extremely new. In fact, this is the first time I'm talking about it in public. I haven't even shared it with the team yet. So it's brand new. It's the alpha version of our web application. It's not publicly available yet. It's just on my computer, and I'm going to show you some screenshots from it. But think of it more like a promise of what we want to do. We're testing currently a BERT-based LLM, that model there that I mentioned, to generate our vector embeddings. But spoiler, it's probably not going to be good enough. It does work in some cases, but so let's just get into that because I know time is an issue here. Also, I don't have to tell you about our pipeline. Of course, there's a lot of work that goes in just getting the texts from their raw form into, say, an Elasticsearch database, which is the back end of our website. There's so much you have to do. It's not just, pushing a button here. You've got to extract the text into text file, generate mappings of all the positions, segmenting, assessing the OCR quality. So lots of stuff that goes on in the background here just to get it to where we want. And each of those steps we could spend a week on, and you have to optimize and so forth and so forth. But that's what's going on in the background. Now let me show you the web application. Some of it I'm going to focus on the text matching part, but there are these other aspects. You can probably see at the top here, there's kind of basically 5 sections to the web app. This is the Explore section where we provide statistics about the corpus. You can see right there, right now, this is coming straight from a Mongo database, by the way. To the website, we have 427,305 metadata records that describe all the books we have. And so this is where someone can learn about the corpus. Then you can do this metadata explorer where you can actually go and look at some of the records and see the rich metadata we have or produced about every single text that's in there. I just want to highlight this one here, language information. So we run language identification against every single text down to about 50 characters because we have so many multilingual texts. We don't want to just use the metadata that says, hey, this is a book in Latin. Well, guess what? It's not just in Latin. It's in Greek. It has multiple languages, and sometimes it's very short sections. So we want to identify all of that. So for example, here you can see we ran it on this text here. We can see that 15% of the text is in Greek, 85% is in Latin. That's good to know. So we can call it substantively multilingual and so forth, and we can do that. We also assess the OCR quality. This is more difficult to do. We don't have access to the ground truth page images, so we're looking at the raw text and trying to assess the OCR quality. You can imagine that's difficult, but we try to do it on a page-by-page basis, not just, hey, this entire book is this quality, but every single page is given some sort of assessment. We'll see whether that works. Of course, most scholars, if they use this, they'll probably jump directly to the search, your normal keyword search section here. I just showed you some example queries. You can, of course, do basic keyword. If you search for Hermes, for example, you'll see that right now I have a prototype. The website is only 132 of our files, not all 400,000, because we're testing everything. But you can still look, the index is already 15 gigabytes just with 132. You can imagine we're going to get up into a lot of terabytes when we put all of it online. We've got 22 documents here that have Hermes in it with 332 total matches, so you can explore all that there. You can, of course, do more. Using Elasticsearch, you can use much more complicated queries. You can do a field query, say, okay, show me all the books by Kepler in the name of the author that have Hermes as a keyword, right? And you can see we have one here from 1621. And you can do much more complicated with ands and ors and nested queries and proximity queries. Those are fun, right? You can say, give me all the texts where Hermes and Plato are mentioned within 10 words of each other. That's fun. That basically already works. We have an analyze section of the website, which is obviously not implemented, but this is the stuff we're going to put on there: topic modeling, latent semantic analysis, some diachronic analysis. So I'm learning from all of you guys about how to do that. So we'll put that on the website as well. We have a read section. Scholars will want to read the text, and not in poor OCR quality, but they want to see the PDFs of every single text we have in there. So we have a Mirador viewer on there, so you can go there and read it just like you would on a library website and get the metadata as well. But that's not the stuff I want to talk about. I want to finish here in the last 4 minutes talking about our match section. So this is where we want to try to find textual reuse between different texts. And I want to draw your attention to a couple different things here. First of all, we have a place where you can search for your query texts and for your comparison texts. You can do single document, so you can compare one text to another text. You can do multi-document ones, so you can say, okay, I've got Newton's Latin optics, or I've got all of Kepler's works that are in the database, and I want to see where there's textual overlap. And we're going to try to do it so you can do one text and see what all the matches are in the entire corpus. Now, as you can imagine, that's going to take a lot of computational power, and I'm not sure we can get it so that the user's going to want to sit there and wait for the results, but that's the goal. Also, we have a lot of options. As you guys know, it's not like you push a button and all these things just work. There are lots of parameters you can tweak, and you have to tweak. I want to expose that to the user so they could, if they wanted, they don't have to, they can change all the parameters and so forth. For example, maybe you have a minimum similarity score. 5 minutes, okay, that's more than I thought. Minimum similarity score you want to use to see what kind of results you get, so you can tweak all that stuff. So what I'm going to talk about here for a case study, well, let me say one more thing here. We have two basic kinds of matches. We have lexical matches, match type here, using keyword matching. So this is, when the vocabulary is going to be similar. Hopefully there's a match there. Then we have semantic matching. So we're going to use vector embeddings to find conceptually similar passages. They don't necessarily have any linguistic vocabulary in common, right? Because lexical matches, they're not going to work across languages. But right, we have a multilingual corpus, so we need something that looks at the actual conceptual semantic content. So that's where our vector embeddings come in. And of course, you can do hybrid ones. We can combine them and do different weights and so forth. Then we have this thing called matching mode. We have a standard mode that you can just use, but if you want to be more comprehensive and really find all the matches, use a bit more computing power, wait a bit longer for your query to do it, you can do that. And we have a faster mode as well. The case study I'm just going to mention, these are kind of more like sanity checks rather than a full case study here, but what happens, and I had it on the previous page, when you take Newton's Latin version of his optics from 1719 here, that edition, compared to the English edition from 1718. Let's say we want to run a match, a text matching for those two texts. They're in different languages, of course. When you run a lexical match between those two, you're not going to get any results. At least that's what we hope for, right? And that's what happens right now, that no matches are found. I will tell you this is using standard mode. If you use the comprehensive mode, you get 3 matches. So there must be a part of, and they're in English. So the Latin edition has some English text in it, probably maybe from the preface and so forth. So those will show up if you use the comprehensive mode here. But for the most part, you're not going to see lexical matches. And that's what we want to see. That's a sanity check here. This is what it looks like. A match summary here. I tried to make it so, we have helpful information about what you're looking at, what happened with the query. So we have a quality score, average similarity of the matches here, and this is what you see. Coverage score, how much of the text have the matches, and various helpful information. You can see here that it did almost 1.3 million comparisons to come up with the answer. Lexical matches here. We also have automatic highlighting that shows the source, the query passage on the left, comparison passage on the right, and the similarity score. Now, what happens when we do a semantic match between those? We hope we're going to get some matches, right? Because here, that one is a translation almost of the other one. So even though lexically they're not at all similar, semantically they better be. If you do that, the matches do seem reasonable. You can see, even though with the OCR issues, you can see, I mean, some of the stuff is just almost like a translation of the other stuff. Let's see, there's one where he's talking about colors here, and they're also talking about colors, and people will be able to explore that. So when we do that sort of thing, it is reasonable. But there's some problems with it. The match score stuff, I think, is not quite built out yet. The quality score, I think, is right here. It is very high quality, but some of the coverage score is off. Now, it turns out that that actually is telling you something. The Latin edition is quite a bit longer than the English edition, and they could be quite different. So maybe it's not as wrong as I think it is. But I've done some other queries here using our embedding model, and I just don't think it's good enough. So to end here, issues on the horizon that we have to think about. I hope you see what we're trying to do. We use this vector embedding model partly because it doesn't generate, it doesn't have as much storage. You can do it more quickly, but it's probably not sufficient for what we need. There are a bunch of others you guys have mentioned. They all have their trade-offs, right? So if you use a more accurate one, it's going to take up a lot more storage. It's going to take time to do inference and all that stuff. Or is it a losing battle? And we shouldn't even use one of these models. We should fine-tune a base model because our corpus is so distinct. I don't know. Also, semantic meaning changes over time. How is a model supposed to handle that? From a text published in 1540 for a text published in 1700 in different languages. Is that really in the same vector space? Poor OCR quality, as I mentioned, it affects everything downstream. If you have poor OCR quality, how do you even segment it into sentences and passages? Right? It needs to know how to do that, but the OCR quality messes that all up. We can't re-OCR the entire corpus. It's not feasible. Do we re-OCR the very poor quality texts? What do we do? Or do we just spend time going out and finding what other people have done and say, look, those are really high quality texts. We're going to bring them into our corpus. We could do that. Scaling and performance, I mean, that's just 132 texts, right? We have 430,000. So that's going to be an issue. And those queries took 15 seconds. How are we going to do that with 400,000 texts? So advice is very welcome. Just a preview here. Thank you very much.
Thank you very much. Advice and comments. That's why we're here. Should we collect, or would you like a quick?
I'd like a nice dialogue, one-on-one.
One-on-one.
Yep.
Okay, so then we try to keep it to the point. Questions and comments and advice. I see one there.
Very nice, thank you. Why you decided to use Elasticsearch, not some triple store?
And not which?
Not triple store.
Elasticsearch is very easy to use out of the box, very powerful because we have a very large corpus. We actually were considering some other options, but that's the one we focused on now. It could be that we change, but I like Elasticsearch. It works well. And it is technically now, we have to use everything open source. So there was a fork of Elasticsearch called OpenSearch, and we might end up using that. But now, from what I understand, the latest is that Elasticsearch is now technically open source again. I don't know. They seem to change every couple of years, but so it's a pretty powerful, and it works out of the box. So yeah, that's why we chose it.
Okay, thank you. Next question. I see one there. Jochen. Mike, please.
Thank you for the talk. I'm always interested, you mentioned this, and can see that it's computationally very expensive. And I always wonder, because I have this problem myself, where do these projects get their compute, especially in the situation where you cannot argue, we have already 1,000 users or 10,000 users, but you're basically developing it, so you're holding it out for an occasional test case and development. So in your case, where do you get the
Right now, we get it from my desktop. My desktop computer is all we have at the moment, but we do have access through the VUB to the Flemish supercomputing cluster. So we have access. We applied for that. We have a grant. So we'll be able to use some supercomputers to do that, at least to help us get this all in place. Now, actually, the web app is going to be on the tier 1 cloud of the supercomputing cluster. So we applied for it. They're giving us access. They're trying to get more researchers to use the supercomputing cluster. So far that works, or will work, we hope. Yeah.
Just a quick follow-up. I mean, my experience with these clusters usually run on some batch systems. So if you want to provide a service, they don't hold out that compute for you. You can run a job, but usually not a service.
Yeah, we'll see. I mean, they're trying something new at the VUB with this tier 1 cloud service. I haven't put it on there yet, so I don't know. You could be exactly right in that it just won't work the way it's set up. But we'll see. We have to see whether this is a new service that's actually going to do what we want. They bill it as that, saying, "Look, we know you guys need cloud services for what you're doing, and here's what we hope to offer." We'll see. That would be great if they do, right?
I have 2 questions in Zoom. I suggest you take this. I can combine them, I think. It's a very nice project, they say. What about handwritten material through HTR? And what about Roman alphabets, Greek? Is there anything else, for example, Arabic? So handwriting and different alphabets.
When the PI proposed the project to the ERC, they specifically excluded handwritten just to be manageable. Of course, it'd be nice if if we could include all handwritten stuff there, but you kind of need to put boundaries over things. So no, there's absolutely no handwritten material that we're including. Arabic is not one of our core languages. We have 6 or 7. I don't know if Greek is technically considered a core language, but we have texts in Greek, and that presents some issues, of course, with the typography and so forth. So no Arabic, but yes, and well, of course, there are lots of Roman numerals. But mostly the Latin alphabet, and that presents enough challenges for us. Yeah.
Thank you. I can see 2 more questions. I couldn't see who was first, but I guess we can take these 2 if you keep it brief, and then we'll see.
Yeah, thank you for the great talk. In my past experience, I've seen that like for historical text, especially your tokenization strategy actually matters a lot. And so I was wondering, are you using like byte pair encoding? Are you using subword tokenization? And if not, like I would, in my experience, like multilingual understanding release sources all the way from the beginning. Like obviously, if you can't solve the OCR issue, the next issue I would tackle would be the tokenization strategy. But I was wondering if you could speak to if you've explored that.
Yeah, it's actually a question I do have. You have so many options, right, to tokenize your texts. Yeah, I mean, we have poor OCR quality, multilingual texts. We have not explored byte pair tokenization. I think it's an interesting idea, right, because that could help with some of these issues. So that's something we'll look at. But right now, no, that's not something. We're not using byte pairing tokenization. But yeah, I mean, I mentioned that pipeline. It's a 15-stage pipeline, and you have to make decisions at every single stage that affect everything else, right? So tokenization, and then segmentation, and then all this stuff, right? And so each decision you make affects everything downstream. And yeah, we have to, as I said, we have to optimize each one. And maybe that's going to be the way to go, right? That's what the large language models do. They go down to that byte level to do their tokenization. So we'll see whether that's something we definitely should do or not.
Thank you for the talk. I wanted to ask about the use of embeddings for multilingual comparisons. So could you comment on what is the current state of the art? And isn't that an issue that if you have one language to do an embedding and another language, how they are comparable?
Yes. Well, so like a BERT-based multilingual embeddings model, what it does, right? It's trained on 109 languages, the one we're using. So it understands the different languages. What it does is it encodes each passage in the same vector space. So it doesn't matter, as long as it was trained on those languages, it doesn't matter that one passage comes from Latin, another one comes from English. It knows all those languages, right? So it's going to encode that information. Everything's going to be in the same vector space if you use the same model. So it has no trouble comparing across those languages. The problems are, so in theory, nice, great. The problem is that it's trained on modern languages, not our early modern languages. The semantics are different. So that's going to, basically what I think is going on when we use this, it works in some cases, but it has so much out-of-domain data. If you include the typography and the poor OCR and all the multilingual mixed texts, I think it basically collapses the model in some cases, and you're not getting very good comparisons. So it's the problem mentioned yesterday about out-of-domain data. I think that's what's going on in some cases with this particular model. And I don't know if some of these more historical-based BERT models or other models would help with that, or whether, honestly, the corpus is so complicated that we've got to take one of these base models and fine-tune it in some way to get anywhere decent results. I do know I gave a talk last year when I used only our early modern English part of a corpus. I took a source text and I compared it across 16,000 other English texts, and it worked pretty well. So you can really see the textual reuse. You could take one of our Priska texts and say, and you could start seeing, and it coincided with research. You're like, oh, Cudworth is taking direct passages from that text, and of course he's not citing it. So you can do it again with the early modern English. But when I throw in all these other languages, that's where I'm seeing some problems that we have to confront.
One last quick question or comment.
Do you consider using multimodal models for processing this? Multimodal.
You mean like vision?
Yes. Vision language models.
We haven't tried that. I mean, of course, we're sticking to open source stuff now, just because we have so much data, we're not going to pay for using although ChatGPT 4 Mini and so whatever, the multimodal one stuff, we could try that. Do you think it would help the vision stuff? I mean, because we're not using it for OCR, at least not yet. I'm not sure what we need the vision stuff for, unless there could be a good reason.
So there are like projects similar that found out it's a solution to use multimodal models in this context because of specifically all the issues that you mentioned.
Okay.
And yeah, OCRs like, yeah, and also pixel-based encoding. It also exists like it also allows you to work with languages which are, you know, rare languages and ancient languages. And I had another question. Can I ask? Text reuse you mentioned. So I think that like to study text reuse, we need like a definition of text reuse. And I think that in our project, we will also come to this. How do you define text reuse? What is a unit of text reuse? How do you handle text reuse in multilingual context?
Well, yeah, these are all questions we have to confront. Right now, we're just taking a pretty simplistic approach, especially for testing. We're saying, and again, kind of what does the intellectual historian look at here? We're taking passages. So we're just saying, give me a group of 3 sentences. That's our definition of a passage. Of course, you could say 4, you could do 2, you got to test it. And we're saying, here's one passage that's 3 sentences, here's another passage of 3 sentences. And we have 2 basic buckets. We have lexical, textual reuse. So are they using the same words? Doesn't mean it means the same thing. Again, you can get, right? You can use the word with lots of different meanings. So maybe that's a false positive. But the scholar is the one who has to follow that up, right? We're not saying, look, our tools give you the final answer. The way I look at it as a historian myself, we're providing tools that give scholars intellectual breadcrumbs to follow up. So it'll show you these passages that lexically match, and then the scholar has to actually do the work themselves, right? And say, they do in fact match. I will actually read the text now. Great. Or not. That's lexical text matching. That's keyword matching. Then we have semantic matching, conceptual. Do the concepts are the same? Is it a paraphrase? Maybe there's only a couple words that match, but the concept is the same. So it's really a paraphrase. Again, imagine plagiarism detection. So that's what we also focus on. Is there a hard and fast definition? No idea. The scholar has to decide, is that really a textual reuse or not? We don't decide that. We give hints, ideas, pathways to explore that for them to follow up.
It's just a lot of material for them. So
it is a lot of material, but we're going to help, right? We give them a list, rank the similarity scores, so they know where to start.